Hi folks, welcome back to an interesting discussion on analysis of variance. Again, my name is Zubair Anwar and I'll be discussing analysis of variance and I'll take a practical example to demonstrate. So as Dr. Holly has discussed a theoretical background on analysis of variance, and you would have seen that ANOVA or analysis of variance is essentially a linear statistical model which is used to compare several population means. Now ANOVA tells us whether there is a difference among means, although it doesn't tell us which means differ. If ANOVA indicates that there is a statistically significant difference among means, a graphical procedure can be used to isolate the specific difference. Now I'll talk about one-way ANOVA. So you see, a factor in ANOVA describes the cause of variation in the data, and with only one factor under consideration, we call it one-way ANOVA with the following conditions. 1. Population should be normally distributed with same variance, and 2. Samples must be independent of each other. Now main idea here is to determine whether the variation due to the treatments is sufficiently large compared to within treatment variation, which is experimental error. Now let me share the procedure to calculate one-way ANOVA. So number 1, state null and alternative hypotheses, which are denoted by H0 and HA. Secondly, we define the level of significance, alpha. Thirdly, we construct ANOVA table, and I will show you one basic ANOVA table in the next slide. Next, we compute test statistic, and then we determine the test statistic critical values in F table using k-1 as the numerator degree of freedom and k into n-1 as the denominator degree of freedom. Lastly, we state the conclusion of the test. Now mind that F distribution is a ratio of two chi-square distributions. Here you see one-way ANOVA table. In the first column on the left hand side, you see the sources of variation, which are between the treatments, within the treatments, and we have sum of squares denoted by SSB. Within the treatments is SSE, and the total is SST. The degrees of freedom is k-1 for between treatments, n-k for within treatments, and n-1 for the total. The mean squares we denote MSB equal to SSB divided by k-1, and MSE, which is within treatments, equal to SSE divided by n-k. And taking the ratio of MSB and MSE, we find out the F statistic. Now see that n is total number of readings, small n is the number of readings per treatment, k is the number of treatments, and SSB, SSE and SST are the sum of squares. Now let me take one example in order to understand how to apply one-way ANOVA. Now previously we have discussed an example in the discussion of T distribution about a production process. Now consider that another parallel stage in this process can be run at 3 temperatures, say 200 degree, 220 degree and 240 degree. Using the below table of 4 batches run randomly, determine whether the temperature significantly affects the moisture content in percentage at a significance level of 0.05. And in the table you can see we have the temperature ranges and 4 batches that have been run with each temperature differently. Now let's move towards the solution. Now here let us assume that conditions are met, and by that I mean the populations are normally distributed with same variance and samples are independent of each other. So we can follow the procedure that we have just described. So the first step, we state the null hypothesis H naught, and we have three means, mu1, mu2 and mu3 from the three populations, and alternative hypothesis which imply that not all the means are equal. The significance level given is 0.05. Now I have provided a spreadsheet that contains all these calculations, which I am now going to show you in the ANOVA table. So here you see that the sum of squares I have calculated. SSB comes out to be 17.69, SSE comes out 3.3, and the total SS is 21.03. Degrees of freedom we have calculated between treatments is 2, within treatments 9, and total 11. The mean square I have calculated. MSB comes out to be 8.85 and MSE comes out to be 0.37. And from these two we can compute the F statistics, which is 23.92. Now we can look on the F table, which is indexed by the degree of freedom associated with the numerator and denominator. In this case, the numerator MSB has 2 degrees of freedom and denominator MSE has 9 degrees of freedom. Now from the table for significance level of 0.05, you can see that we can find F critical value at second column shown by a red rectangle in this slide, and the 9th row shown by a blue rectangle in this slide. We come up with the value of F critical as 4.26, and I have shown it in a probability plot above this table that 4.26 is the F critical value and the rejection region lies on the right. So it's right tail distribution for the rejection region. Now we have computed the test statistic, which is 23.92, and you have seen that the critical value at this level of significance is 4.26. So since this is one rejection region right tail test and the test statistic exceeds critical value, so the null hypothesis is rejected, and we can say that at 0.05 level of significance, the given data indicates that temperature is in fact impacting the moisture content. So this concludes my talk on analysis of variance. If you have any questions, please feel free to reach me. Thank you very much.